this video we are going to look at addition reactions. So kind of does what it says in the tin really, where you're adding one thing to another. Okay, so unlike substitution reactions, nothing is being taken away from either molecule or anything like that. You have two things becoming one. In this as well, you're going from planar molecules to tetrahedral ones very often. Okay, so two reactants making one product. The addition of something will be added across the double bond. So you see here, you're starting with C2H4. So you're starting with an alkene. You're adding H2 to it. This is in the presence of a nickel catalyst. And you see the two hydrogens are added on. And it, for all the world, removes or takes away this double bond. Okay, so there's no double bond in this C2H6 over here in your alkane. It's all single bonds. So that's a very easy way of spotting an addition reaction, is that if you're going from something that has a double bond in it to something that only has single bonds, you have added something on. Similarly, if you start with an alkyne, okay, with the triple bond in it, and you go to something with only a double bond, you'll know that something has been added on to it as well. We'll see a little later on. And here then, if you have an alkene again, C2H4, you add water to it, well then you come out with an alcohol at the end. Okay, so here's so addition reactions. So if we start with an alkene, okay, and you add water to it, you see there in the last slide we came out with an alcohol. If you have an alkene, like we had in the last as well, and add hydrogen to it in the presence of a nickel catalyst, then you come out with an alkane. Okay, if you have an alkyne, and you add hydrogen to it in the presence of a nickel catalyst, you come out with an alkene. Okay, add bromine to an alkene, you come out with a haloalkane. We'll look at that mechanism in a little bit more detail in a while, and then at the end we'll come to polymers. Okay, so we'll just quickly take a look at some examples of some addition reactions. All starting with ethene. So if you have H, okay, and if we add hydrogen, this would be called hydrogenation. If you're adding hydrogen to something. Okay, this reaction in particular takes place with the nickel catalyst, and at the end you come out with ethane. Okay, that's your first example. Second one then, again starting with ethene. If you want to add bromine, Okay, and we're going to look at the mechanism for that in a little more detail. One of the uses of this is that it's a fumigant. Okay, against insects, so it's basically a gaseous insecticide. Okay, and then we just have a look at some other examples. So ethene and chlorine, you'll come out with 1,2-dichloro ethane. Okay, that can be used to make vinyl chloride. If you add many of those together, which we'll see later with polymers, you can create PVC, which is plastic. Okay, and you use for various things. One of those is to make toys. Next example then is ethene plus hydrogen chloride. You come out with chloroethane. That can be used for diagnosing dead teeth. It's also used with cellulose as a thickening agent and binder in paints. And the last example, which we looked at already a little bit, is ethene and water. You come out with an alcohol, so in this case you come out with ethanol, and of course that's used as an industrial solvent and a fuel. Okay, the mechanism we're going to look at in this video is we're going to focus on the ethene and bromine. So the mechanism is basically how it works, okay, and how it takes place. Alright, so our first step is polarization. Okay, so if we have our right, that's our ethene. Alright, and we're adding it to BR bonded to BR. Okay, so as this BR2 molecule comes close to the ethene, it becomes polarized. Okay, this region here where the double bond is, that is electron rich. Okay, so as this bromine molecule comes in closer proximity to it, this becomes polarized. Okay, for electron rich here, the positive bromine is going to be this side, and this bromine becomes negatively charged. Okay, so our molecule becomes polarized, so one side is positive and one side is negative. Okay, there is a repulsion by the electrons in Okay, so once that has occurred, so that's our polarization step, step 1. Step 2 then is heterolytic Okay, so if you have watched the video on substitution reactions, we would have come across this. Okay, so substitution, you go with, when you're using a free radical mechanism, uses homolytic fission, but we did look at heterolytic fission as well. Okay, it's when all the electrons in a bond go with one molecule and the other molecule doesn't get any electrons. Okay, so if we have our BR, Okay, we know that in this bond there, that represents 2 electrons. Okay, 2 electrons between the molecule, or between the two atoms of bromine. When this is broken, all the electrons go with one or the other. Okay, because up here we said that this one becomes negative, or the way it's polarized is that it's negative. All the electrons go with that. So your electrons from this are all going to go with this bromine. So we're going to have Br plus, and then you're going to have Br minus that has 2 free electrons in it. Now, our third step. Okay, this is carbonium. This is your carbonium ion formation. Okay, and this is an intermediate is formed. So we have to draw our ethene again. Okay, in this, right, we're just concentrating on this Br plus, right, because this is kind of a high density of negative charge. That's why the Br plus is the first one to be added. So this Br plus is going to be coming in close proximity to it. Okay, and one of these bonds is broken, if you like. And then we come out with this structure. Now, okay, it's a carbonium ion because this carbon becomes positively charged. You'll see carbon usually has 4 bonds coming off it. In this case, it only has 3. Okay, so it is positively charged. Okay, it needs that extra bond to become neutral. Okay, the thing about this particular mechanism is that this bromine molecule is actually quite large. Okay, so if you look at where it is in its periodic table, it's quite a large molecule. So actually what can happen is that a cyclic structure is formed. So you'll have the same thing here, you'll have H, you're into carbon. Okay, but here, your bromine. Okay, so this structure here is a cyclic structure, so it's a cyclic and that just happens because the bromine molecule is quite large. Okay, and then this last stage, step 4, is your ionic addition. So we have this structure here. I'm going to bring it down. Okay, we have our bromine ion, which is negatively charged. There are 2 free electrons. Okay, and that is going to, we'll use the term attack here. Okay, negative going to the positive charge. And that is going to form what we want in the end. And that is our 1,2-dibromoethane. Okay, there are a few pieces of evidence for this mechanism if you want to take them down. It's that ethane reacts with bromine water that contains salt, NaCl. Okay, compounds are formed during this, so 1-bromo-2-chloroethane or 2-bromoethanol is formed as well. The formation of these products is evidence for the existence of that carbonium ion. So this structure here. Okay, so that is how that happens for bromine. You also have to know the mechanism for the addition of chlorine to ethene and for hydrogen chloride to ethene as well. The mechanism is the exact same as bromine. The only difference is that this cyclic structure cannot be formed. Okay, so it cannot be formed in the mechanism for ethene plus hydrogen chloride or for Cl2. Okay, it's because these molecules aren't large enough. Okay, so this here only happens with the bromine, the cyclic structure, because this bromine is very large. Now, if we go on to our last type of addition reaction, we will look at polymerization. Okay, what polymerization is adding short chain molecules in order to create a long chain. So a polymer, if you ask what a polymer is, okay, they are long chain molecules made by joining Okay, so it's a repeating unit. So part of a polymer whose repetition produces complete polymer chain, except for the end groups. Okay, so a polymer, the main chain in the center of the molecule will be the same unit repeating over and over again, but there may be a difference at the end of the chain. Okay, so the end group might be different to the rest of the molecule. So if we have a look at a few examples. Okay, so if we look first at polyethene. Okay, so we've polyethene, so ethene, we've seen the structure of it already. Okay, when you join many of those together, this double bond doesn't exist anymore.
Let's take.
Okay, so this in a polymer, if you have many units of them joined together, you're going to have all carbons. So if we go for 3 molecules of them joined together, okay, so that's 3 molecules of them, so C2H4 is ethene, so that's 1 molecule, that's 2, and that is 3. Okay, and they keep repeating over and over again. Now if we look at polychloroethene, okay, if we just had 1 unit of it by itself, it would look like that. Okay, that's just 1 unit of it by itself. This is if it was in the middle of a chain. Okay, if this just existed by itself, then there would be a double bond. Okay, if you have many units of them joined together though, well then you're going to have this sort of a structure forming, okay, and that can repeat on and on and on. So this is PVC, so polychloroethene, and that is basically making plastics. Okay, and then last one then that we'll look at is polypropylene. Okay, so if we just had 1 unit of it by itself, okay, this isn't the structure of propene. Okay, this is if this is in the middle of a polymer. Okay, so this would be in the middle of polypropylene. You would have this. Okay, and if you had polypropylene, many of them joined together, well then you're going to have many of them. Okay, and you just keep adding them together, and the chain becomes longer and longer. And that is our addition reactions. And here's just a better visual maybe of the molecules, better than I can draw.